Okay, so picking up where we left off, this time we're going to do the domain for letter F, which is going to be the same answer as E because it's basically the same graph, it's just changing in how fast it grows. So 0 to infinity for both domain and range. And then we have letter G with two transformations. So whether you go down and then left, or if you go left and then down, it's going to put you at the same point. So your new graph should look like this. So for your domain, it looks like it's going to start at -2 and continue forever to the right. For your range, the lowest point is -2 and then it just rises. So quick rule of thumb, if you're doing even indexes, so like square roots, quartic roots, sixth roots, anything that's an even type of root, if you want to find the domain pretty quickly, you can just set your radicand greater than or equal to 0 and then solve. Good news is if you have an odd index, so if you have like a third or a fifth or a seventh root, your domain is always going to be all reals. So it does say find the domain and range of each function below. We're just going to find the domain for today. So this is a square root, so you just have to take what's inside the 2x minus 7, and you have to set that greater or equal to 0. And it should make logical sense because you can't square root a negative number. So anything equal or above 0 is a positive number. And that's what we kind of want to get. So if I were to solve this, I would get 3.5. So you could either write x's have to be greater than or equal to 3.5, or you can turn it into interval notation. Number 2 is the exact same scenario, except I used exponential form. So what I'm going to do is I'm going to change this into radical form, so it looks more like number 1. And I don't care about what number's out here when it comes to domain. I just need to make sure that this inside is greater than or equal to 0. So that's what I'm going to set it up. And anything above or equal to -3 will work in number 2. Number 3, I don't have to do any work at all because it's an odd index, so I just write all rules. Number 4 is a fourth root, so I do have to go ahead and use that greater or equal to 0, and we're going to get less than or equal to 4/3. And if you want to do interval notation, it'd be -infinity to 4/3. And then number 5, it's up to you if you want to change this into a radical format, or if you pick up on the fact that this is a 1/5, great. But it's an odd root, so there's no need to check anything. You can put anything you want in for x, and you can always do the prop.